Okay, we're going to do some logic problems. First, we're going to talk about the if-then statement. It's also called a conditional statement. And it's if hypothesis, then conclusion. Okay. Hypothesis is the if part. The beginning. The conclusion is the then part. Okay, so we could say something like if a angle equals 90 degrees, then it is a right angle. Okay. This is my hypothesis. This is then my conclusion afterwards. Okay. So negation, making it not. Make it the opposite. And this is dependent. If there was a not in there, you would not put another not there. You would take it out. So this is if a angle is not 90 degrees, then it is not a right angle. So again, that's what negation is. It's changing it to not. Then we've got symbolic form. P to Q. If P, then Q. We often do symbolic form for this. P in this case stands for the hypothesis. Q is the conclusion. Okay? It doesn't matter which letter you use. It's just a shorthand of doing it. So letters don't matter. You're just using letters in place of the whole word. It's just a shorthand. And it can also, when we say P to Q, that means, P implies Q. Okay, let's move on to truth values. Okay. So it's just stating whether it is true or false. Whether your statement is true or false. Okay, and it's just like the whole statement saying it's true or false. And in a lot of cases, it doesn't matter. Law of detachment. In a valid if-then statement, the conclusion is always true if the hypothesis is true. Okay? So if a triangle has two congruent sides, that line means congruent, then the triangle, and I'm obviously drawing a triangle instead of writing it, is isosceles. Okay? Can't conclude that it's isosceles without two sides being congruent. If this happens, then this is automatic. Okay? So now we're going to talk about the law of syllogism. Okay? R goes to S goes to T, T goes to U. We're assuming that R starts off as the hypothesis, S is the conclusion, then S is the hypothesis, T is the conclusion, then T is the hypothesis, U is the conclusion. This means R is true. Hold on one second. We'll fix this. Hi. There we go. Means R is true. Then U is true. So we do this, therefore R goes to U. That's a law of syllogism. And we sometimes see therefore as these 3 dots. It just means therefore. It's just a shorthand. You know, mathematicians love their shorthand. Less writing. Okay, we're going to start with this conditional statement. If two lines are perpendicular, then they meet at 4 right angles. The inverse means we're going to change this to not. And we use this little symbol right here to say not. So we're going to change this to the inverse. So we're going to say if 2 lines are not, and I'm going to use the shorthand for perpendicular, just a symbol, then they don't meet at 4, and this is a shorthand for 4 right angles. Okay, so that is the inverse. Converse is you switch it. You're going from P to Q to Q to P. Okay, so we're going to say if 2 lines meet at 4, and I'm going to shorten this right angles, then they are perpendicular. So I've switched it. Okay, I've changed it from the conditional statements to converse by switching the hypothesis and the conclusion. Contrapositive is doing both. You're going from P to Q to not Q, not P. So it's both the converse and not. So we're going to say if 2 lines don't meet at 4 right angles, then they are not perpendicular. Okay? So there is something, you know, like this is all about truth values. You could have the statement be true and the inverse be true, but the converse might not be true. And then the contrapositive, you know, may or may not be true. These are all important to look at. Each different one can be true. But this is an example of the inverse, making it not, converse, switching the hypothesis and conclusion, and contrapositive, switching the hypothesis and conclusion and making it not. And that's it right now.